Yeah,
Oh,
I
so
got,
you either have to do
my
one
printer
of
was
the
186.
brackets first, and then write it, or do
because I added the 50 and the 30 point whatever, and then I added the 3 dots and the 12 feet.
I think what I did is I minus 3
Oh,
instead of added them.
Okay guys, let's break it down and then we can just work through it together. So what did you guys do as the first step?
well, added it up.
Added it up, right?
Yeah.
I like converting
Yeah.
these to decimal.
Yeah, 0.75.
Right, so what do we have for our center line parameter? Equals 30 foot 9, which is 30.75.
Yeah.
Right, 30.75 plus
I went 50.
plus 50.
50, yeah.
Right? 50, perfect. Plus,
That's where it went wrong.
Plus the 12, or came up to,
Yeah.
16.58.
you want to take, so you want to take the 6.75 again?
yeah. It's just 13.5.
What I do is like, I don't do the whole, for me, I just break that down and I get that number first. And
Yeah.
then I minus.
Yeah, I added both sides.
So you
That's
added,
what I
you added both
did.
sides?
Yeah, that's what I did.
That would work too, like I did that, that's what I did with the math, I did,
Yeah.
you could do this plus this,
But I did one
and
side.
then you could add those two together,
Yeah, okay, yeah.
and then add that to
Yeah.
the total, that works
Yeah.
too.
Okay.
But for this sake, it's, what's the math on that one? It's, can someone do the math on that one, please?
80 points.
We'll just like break it right down, like we don't have to do the multiply two at the same time. 79.2,
No, it's 87.5.
87.5, is that the right one?
Yeah.
Oh, I see. 79 was after I subtracted.
Yeah.
Plus 50, 6.75 equals 87.5.
Yeah.
I was just telling myself.
So 87.5, so that gives us our lengths, but then we need to multiply that by 2. So that only gets us pretty much this and this. I don't know if this visual will help you guys, but it helps me, so I'll just explain
Did you-
as I go. So that gives you this, and one of those, and that's it.
What about the 12 feet at the corner?
Yeah, I'll get to that.
Oh, okay.
So then you multiply that by 2 to get your total. So 87.5 times 2 equals 175.
Yeah,
You guys get that?
yeah.
Okay. So for the 12, I'll explain that. So you imagine that you don't need to calculate this jog. Because the way it works
Yeah.
is, if you imagine it like this, if you cut it off there and move this up, that brings you
Yeah,
here, right? And then if you cut that one off and move it that way, that brings you there.
It's exact same.
screw this.
So that jog does it like that. So that number, you don't really.
Yeah, okay, screw that.
The different thing is though, is this part,
That you do.
you need to be aware of, you do need to add these because it's not a jog, it's a cut. But the way that I imagine it is, I cut it like this,
Drop straight down.
and then that one drops straight down.
Yeah,
So you have that length already included in your 50 feet. So then you only need to add 6'9". You have that measurement from here to here
yeah,
twice.
yeah,
So that's what gives you that. That make sense?
yeah.
Okay, perfect. So we got 175 as our center line parameter.
Yeah, screw it. Yeah, minus 12.
It's all good, it's just, that's how
I gotcha.
For me, like that's when I'm doing it on the test, I visualize it like that, I actually cut it off, and I actually draw it in, just because for me, I'm visual, and I need to see that, you know? So our center line parameter is 175. Okay, so we can do, let's do our footings first.
You have to subtract the corners.
Oh, sorry, yeah, you need to subtract the corners, my mistake. That's the next step. So you gotta go, your center line parameter equals 175 minus the corners. So the corners are 4 times 0.83. Does that make sense? Like the same, you still have 4 corners with
Oh,
it?
you don't count up the total number of corners?
So these ones here, because the way it's measured here, this is how I understand it, is you don't have the overlap, you know what I mean? So say your wall is actually finishing your 50 feet,
Right,
it gives you this and this, even though my walls don't line up, but
so it's always just 4 corners.
not always, like sometimes you may need to add a corner, but in this case, you need to visualize what corners are actually overlapping, you know what I mean? So this corner, say you move this bit down to here,
Right, I see.
there's no corners overlapping, you know what I mean? In this case, that overlaps and that overlaps, right? But in this case, it doesn't, because you have your measurement 6'9" to here to here.
Mhm.
If this 6'9" measurement was only to this, then it would be slightly different. You know what I mean? Because your 6'9" would be, you would need to cut it here and here and move that down. And then you would have overlap. Does that confuse you guys at all? Or like, essentially like, if your 6'9" measurement didn't come to the outside of the wall and it came to the inside of the wall, you'd have more material there.
Yeah, if it came to the inside of the wall, then you'd have to add.
In that case,
but
then you
it's
would
all
have
to
to
the
add-
outside, so we
Exactly,
don't need it.
exactly. So that's where it comes in with the centerline perimeter, is doing those, visually seeing how you cut it and where you move it to. Make sense? So that's where we're at with this one. What was the math on that? I had 171.68.
Yeah.
Yeah. Sorry?
We have 171.19.
0.8? So 4.175 minus, you wanna just double check, we can double check that? Is that,
Yeah, that should be right.
should be right?
Yeah, that's what I got.
Yeah, I got that too. Yeah.
2.
You got it.
Okay.
So that's your centerline perimeter for that. Any questions on that? So it's just those little things that throw you off, you know what I mean? Especially for the centerline perimeter, and like, I know like we're doing a lot on this one, but like, it, you know, to understand it, that'll be a couple marks on the test if it's on there, you know what I mean? And they, you know, this is part of the red seal.
Yeah, Rodney said there'll be centerline stuff on.
Yeah, yeah. Oh, did we want to
Yeah, he
say
told me,
that?
yeah.
Perfect. That means I know what I'm doing. Okay, so from that, then you can get your footings and your walls. That's pretty
Yeah.
straightforward.
Yeah.
So it's getting that centerline perimeter. This is more complex, so just to think about it, but just visualize, actually draw out where the actual walls are going to be, and you'll be good to go. So for the footings, what do you got? You got the centerline perimeter, so 171.68 times
Two
width
point
times
three
that.
three
Yeah.
three times 0.666.
0.666 or 0.83?
What was
0.3.
10 inches?
0.83.
0.83, right?
Oh, sorry.
Equals 332 feet. 332.01 square feet.
Yeah.
On this one, they convert it to yards. So it depends on what they ask you on the test. They may ask you to convert it to yards, meters, whatever they end up doing. So if you want to convert square feet to square yards, you divide it by 27. That makes sense. There's 27 square feet in 1 square yard. Okay? So we'll just leave it at this one for now. If you wanted to convert it to meters, square meters, or cubic meters after the fact, I don't know if you guys want to write this one down. It's 1 cubic meter equals 1.30 cubic yards. 1 cubic meter equals 1.30 cubic yards. Okay? And then the reciprocal of that, what is it? It's 1 cubic yard equals, what's here? 0.7646. So you may not need to use that, but if you need to convert it at the end, like say you do a calculation like this and you want the final answer in cubic meters, chances of them switching between giving you measurements in metric and converting it to imperial at the end, or likewise, they would ideally do the same thing all the way through, but just in case, it's just good to know. Okay, so let's just do the walls, guys, and then we can move on. Up to that point, is everyone getting it pretty much? So for our walls, you have 171.68 times 0.83 times 7.67. What'd you guys get on that one?
I'm actually way behind. I'm catching up here because I realized when I first did this, I just added the numbers straight across in my formula. So 30'9" plus 50 plus 6'9" times 2, and when I did it in my calculator, because they weren't in brackets, that's 6'9" was
Yeah.
being times 2, and then so I'm behind on the whole thing right
Threw it
now.
off.
Yeah.
Those are things, especially with the calculator, it's just, that's why I like, for me, I like to simplify it, so like I'll do this equation first, get the number, especially when it's in brackets.
Yeah,
So,
I made a big note on it and highlighted it so that when flipping through later, I can remember brackets separate.
Yeah. Okay. Someone get the final note for the walls there?
1092.92.
Yeah, perfect.
Yeah, what I did, I added the 6'9" twice, and that's not right, eh?
No. Well, you could do that as long as you do the math
As long as you do
sequencing correctly.
Yeah,
Like,
yeah.
you could just do it times 2. When I did it, I did both, and
Yeah,
they
yeah.
both added up to the
They
same
both
one.
add the same.
But as long as you did the sequencing right?
Yeah.
Like you could do this and then this.
Yeah.
Add that together.
Yeah, and then.
Equals,
do-
and
oh,
then,
okay,
and then
yeah,
add
yeah,
6'9"
yeah. Okay.
and 6'9".
Yeah, that's
and
right.
It should be the same if you do the,
Okay.
but with the calculators and the brackets, the sequencing on it might get a little tricky. So that's why I just,
Yeah.
I break it down even more.
Yeah,
Okay. Square feet. So for that, if you want to convert that to square yards, you just divide it by 27. Okay. So they may ask you in the test, do the math, convert the final answer to square yards, and then whether or not they'd actually have that on the formula, I'm not sure, but it just something good to know. 27 square feet in 1 square yard.
There's 3 feet in a yard.
Linear feet, yes.
Yeah.
Yeah, square feet, it'll be, okay? So your final answer on that one would be 1092.93. That gives you pretty much 40.5
Square
square yards, yeah.
Yeah.
Okay. Make sense, give or take? Got some mistakes sorted out? Beautiful.
I'll let you in my contacts, don't worry.
You're working on it, scratching your head there.
No, I got it.
Yeah, like I said, guys, like feel free, like obviously, like I won't be just staring at my phone. I'm calling you anytime, but if you call me, leave a message, I'll do my best to get back to you. You know what I mean? If there is any issues and you need clarification on these types of things.
It'll be one of these, oh, it's that Rod guy again. I gotta change my number at 4 o'clock in the morning every time.
Hi, it's 3:30 in the morning. I hope you got my message from 12:30. My exam's tomorrow.
Okay, so this is, I'm gonna get rid of this. You guys got that for the most part? The eraser very good, but should be okay. Okay, moving right along here. So let's do a couple fancy silos. So we'll do a hexagon and octagon, which it's a pretty easy calculation for the perimeter of it, which is literally one side times 6 for the hexagon, one side times 8 for the octagon. I looked at it and I was like, I know that. Okay, so let's do an octagon silo. You know an octagon silo on the board. Do the same process as That's page 146. It's kind of the same process as the cylinder silo, except it's just a different formula. Okay. So we'll work through this one together on the board with the octagon. Its size, I'll try to draw an octagon here. Here's my octagon, kind of. Just for the sake of visuals, it's pretty challenging to draw a perfect octagon. So your perimeter for an octagon is just P equals 8 times the length of one side, because all sides are equal, right? So if one of your sides is, say, let's just do this in, for the sake of easy measurements, in metric for, let's say, I don't know, 2,000 millimeters. This is a smaller silo. So one of your sides is 2,000 millimeters. So for the perimeter, you put 8 times 2,000 millimeters, or 2 meters. Make sense? This would be 16,000. Or we just convert it to 16 meters. So your total width around is 16 meters. Okay? So that's your perimeter. So we'll just follow the same process here as the cylinder one. So that's your area. That would be like your full area of the top. So for the inside, so it's essentially taking the area of the top. This is your full area. We need to minus the inside.
Oh, it's just your perimeter
Yeah.
length, isn't it?
Not
Yeah.
the outside? Just the outside?
Sorry, that's just the perimeter.
Yeah, it's just the
Sorry,
outside.
where did I have the area?
So now wouldn't you?
Yeah, sorry, perimeter first, then area. It's up here.
Yeah.
That's the fun calculation. Here. So the area of the octagon is 2. And again, like I don't think you guys are going to be expected to memorize this. 1 plus the square root of 2. A squared. A is your side. So in this case, A would be your 2,000. Okay?
It's a 2 bracket 1 plus root 2. Is that what you?
2, yeah, that's a bracket, yeah. 1 plus the root of 2 times the square of one side. So that would look like,
2
Area.
times.
I'll break it down here, so 2, 1 plus,
Here it is here.
times the square root of A. So it'll be, are you guys okay if we just do meters instead of millimeters?
Sure.
Just for the sake of, so 2 squared. So that would be your area of your octagon. I had a brain fart there when I was saying the perimeter. But. So again, the reason, I don't know, they didn't give you formula calculations, and I can't expect you to memorize that formula. And I don't think they would either. So if there is like a complex, something like that, then they should give you that, So what's the math on that one? That'll be 2 square roots plus 1 equal. Pretty much this kind of number here is 2.4, rounded up 2.41 times 2 squared. So to do that, you have 2.41 I got 19.28.
19.2. Yeah,
Yeah.
come up with that.
So that'd be your area, that'd be your whole top area.
Must be doing something right.
The octagon. That makes sense? The octagon, it's kind of, I don't know if there'd be an octagon on your guys' exam, I can't say yes or no, but, again, it's in the curriculum, so it's just something that could be there. If they give you an octagon without giving you the formula, I complain. If I were you, because that's very unique.
We'll go at the bottom part, really, on the two
Down here?
4.1.
Yeah, so 2.41, so that's your,
2.41,
where'd I get that? So that's this formula here, so how it's in brackets.
yes.
So I like to just do the brackets first, and get that number, and then add on the other. So that's 1 plus the square root of 2.
So that's the basic formula that you use for every octagon?
For every
No matter
octagon.
what size it is?
Yeah, exactly.
Gotcha.
Exactly. Okay, and then 2, when I put A here, that's your length of one side. Length of one side or A.
Yeah, I got you now.
Make sense?
Yeah.
Perfect. So we'll put, I'm just gonna put that number up there, and then we'll do the inside one, and then that gets removed from that, so that is, that's meters squared is the area of the full thing, so now we need to remove the middle,
Take it out.
take it out, because it's a silo.
Oh, yeah, it's hollow. I thought it was,
Okay.
okay.
You guys following that?
Yeah, I know.
Ish?
Go for it.
Perfect. So, so guys, that was I'm gonna confuse you guys, that was my mistake. You actually don't even need the perimeter.
Because you gotta, what you
That
wanna
was,
do.
that was my mistake.
What you wanna do is not come from one side to the other to get the radius, right? Or the diameter. Or no, you can't, because it's an
You
octagon.
wanna do the
Well, essentially-
area of the inside one.
Essentially, I gotta give you a size for that one, you know what I mean?
Yeah,
So like, I could just say like, you know, this one is gonna be 1,500 millimeters
thickness?
for the inside side.
Oh, okay, I got you. Yeah, it's smaller.
You know what I mean? Like, I don't have to, like, if you gave me some calculator, like,
Yeah,
I
yeah.
gotta give you that information, right? So I might have thrown you guys off by doing the perimeter in there, but I didn't, that was my mistake. Okay? So for the inside, so we gotta do the area of X here. So just the same calculation, so your A equals 2, 1 plus square root of 2
Yeah, okay.
times A squared. So it would be 2, 1 plus 2 times, I'm just gonna go 1.5, again, just for the sake of meters.
Yeah.
You guys understand what I'm doing there? Just keeps the numbers a little bit lower to make them a bit. Okay, so, when you guys do that calculation?
Yeah.
See how it works out? At 10.86. You know, yeah, same thing. Meters squared. So that's your inside hexagon, or octagon, sorry. Okay? So you guys understand, you know, removing that from the total circle, right? The 19.28 minus 10.86 gives you your size. .42. 42 meters squared is your outside. outside line. And that's what you get, to get the volume, you would just multiply that by the height of the silo. Got it? So if your silo is 10 meters high, just multiply that by 10, 11 meters high, multiply it by 11, whatever the height is. Understandable?
I don't get it at all, actually. I've been struggling with the first part of this,
For the octagon?
yeah, so I've got the 2,000 millimeters for the one side, and then I have no idea what all these numbers in the formula mean.
So the formula itself, like the rectangle, regular octagon formula, is just,
Like, there's the 2 at the beginning.
that's just the formula.
Oh,
So
okay.
area equals 2, this is just the generic 1 plus square root of 2 times a squared.
So is it
That's just your generic octagon formula for figuring the area of an octagon.
So is that 2 times everything in the brackets, or?
Yeah.
Oh, okay.
So you would go 2, so your sigma sigma 2 times
You're moving that whole thing.
Bracket?
That's the area.
times
There, and then
a
if you want
squared.
the,
Oh, okay.
So A is gonna be your side, your length of whatever the side is.
so
One
it was
side.
like 60.
Oh, okay.
times that number by
This is just a complex formula, I want to just go over, just to
Area, right?
wrap your guys' head around, like, not to stress you out and worry that like this may be on the test, but just to know that this may be something you may need to figure out.
Mm.
That's when your old history guys are looking at the stars and made that thing up, and then that's just the way it's been.
Yeah. Yeah. Pilot, just all hanging out,
That's it.
years, working it out.
Okay. Makes sense.
That makes sense? I just wanted to do that one just so you guys had an idea of it too, like I said. I wouldn't imagine that they would give you that without giving you the
If
formula
I
as well.
remember right, they would give you the, with the question, they'd give you the
The formula,
formula for the
Yeah.
area.
definitely.
Yeah, well,
And I would think so too, and that's what they might even just, instead of actually giving you the formula on a separate sheet, they might just have it included in the question. I'm not sure how they would work that out. But again, that'll be something I ask them when I talk to them, just to get the clarification on that.
yeah, I don't know what this means, but I think this was easier for out in the circle.
That one?
Yeah.
Yeah.
That's kind of weird.
Alright, there you go.
Well, once you do the formula.
Yeah, that's right, that's
It's
exactly
the
what it
same
is.
kind of idea, like once you have the formula, it's all the same process.
Yeah,
It's
pretty
just
much.
This is a different formula.
Yeah, once you have it.
Yeah. Okay.
If you get it.
Yeah, if you get it, that's right.
If you don't know the formula for a dexa-tetrahedron, well, it's your own fault.
What's that, there's another one, they have a few other sayings over there. One guy said, if you know this, and the initials or whatever was the word, if you know that, you'll never feel any. They all stand for something, right?
There's a couple there, there's a couple there.
The one King Henry didn't die from drinking chocolate milk, you know that one? That's all your, you don't know, you ever heard of that one? That's
I'm not sure
your,
what you're talking about.
all the symbols, like King Henry didn't die from drinking chocolate milk, that's your kilograms, your mega, and that's
really?
all, yeah.
Oh, like it's like.
It's just like
a
a
way to
Oh, way to remember.
Yeah. Yeah. Hooked up with my kid.
I gotcha.
But that's another story.
Okay. Some more fun math. So now we're moving right along here. Has anyone done, like I was asked earlier, but was anyone done figuring out stair calculations for
Concrete?
concrete?
Long time ago.
Yeah, I said them.
So yeah, we'll do a review of this one. So this is something they may ask you. They may give you a drawing like this, say how much concrete do you need for this drawing. So again, I'll give you the process. Essentially, it's the same idea, like just by looking at it now, you essentially break it up into sections, right? Like you would do, like I'll go through the process, but just to tell you guys while it's here. You break it up, so you get one top slab, say you do a line here, you do a line here, and then you actually break this down too, so that you actually,
You soft it and then you just like.
yeah, exactly. What do they call it? A different, what's the name of the, they call that a throat. So for the sake of the formula, this measurement here, your 125, or here to here, they call that your throat.
Okay.
Okay, so essentially during, when we were going to the formula, the throat
There, the
is gonna be one part, and then you essentially do the triangles
Oh,
separately.
okay, so then you just kind of square that off?
Yeah, exactly, yeah.
Okay.
So it's the same idea, you get the area, and then multiply it by the length. So this one takes a bit longer, so we'll do it all together here. And I can even draw it up on a board too as we go, if that helps. So, describe methods of calculating the volume of concrete in concrete stairs. There may be different methods that are used on the job, but for the sake of the exam, this is kind of the method that you would go with. Volume of concrete for stairs is calculated in 3 steps. First, the stair soffit slab, then the triangle shapes formed by the risers and treads, and then the landing slabs. So when they say stair soffit slab, like that would be your stair soffit length. So when I call it like that measurement is the throat measurement,
Yeah.
but they're referring to that as the stair soffit slab. Okay? Okay, so this one here, they've already given us the breakdown of what the stairs look like. Do you guys want to run through it on paper, and then we can run through it on the board as well? What's the easiest way for you guys to think? Here, I'll just review it first, and then we can make a decision what we want to do. Volume of concrete and the stair soffit slab. So they give you the unit rise versus the unit run. So they're taking 900 divided by 5, 1040 divided by 4. So that is taking the rise right here and dividing it by the amount of stairs that they have, because they don't actually give you the measurement. Okay? And then they're actually giving you the unit run too, is 1040. So with stairs, there's a certain degree of overlap that becomes uncalculable, and I'll mention that later on. So like for example, you have the rake of your stair. See how it cuts back a little bit?
Yeah.
You get your 25 almost in.
Yeah, exactly. Yeah. So it'll address all that as we go through here. Hypotenuse of the unit rise / run triangle. Sometimes the hypotenuse is called the unit of bridge. So essentially what this is your a squared plus b squared equals c squared. Okay. So that's taking your unit rise and your unit run. So that's your unit rise here. You guys see my mouse okay?
Yeah.
Yes.
And then that's your unit run. So we're calculating this length here.
It's 180.
Yeah.
It's 180.
So that would be 316 millimeters. Does that make sense? So that's your stair.
180.
So you got your stair is